What is going on, guys? Today I wanted to show you how to do some basic math inside of Python. Now, I've never been such a huge fan of math, but math is very important. So today we're going to be going over some of those simple mathematical operators, as well as PEMDAS, the order of operations, some of the basic things. Most of the time when it comes to coding, you don't need to know very complicated math unless you need to have a very complicated application. Some of these complicated applications might include creating software for graphics in a video game, but usually you don't have something too complicated. So we're going to be going over adding, subtracting, dividing, multiplication, something called floor division, modulus, and finally exponents. That's enough introduction. Let's get right into it. So let's start out with the math operators. We've already seen a couple of these throughout lesson 1 and 2. Let's start actually using some math with it. The first math operator that we're going to go over is the minus sign. So I want you to create a variable called equation, and we're going to call all of these equation. I'm going to say 10 minus 3. So this is the minus sign. We've seen this once before, but I want you to notice that there is white space around this. Now, it is a good practice to have white space on either side of your operators because of legibility. This actually will run, and I can prove it to you if we don't have that space there. If I print equation and hit run, you can see that it prints 7. 10 minus 3 is 7. Still works. Even with that white space, it prints out that 7. This is pretty common throughout all coding languages. You should typically have white space around your operators. Remember, most of your job is probably going to be reading someone else's code, or you might be reading your own code just down the line. If you don't remember how you wrote it, which might actually happen in just a couple days, this might confuse you. So if I did not have this white space here, and I did 10 minus 3 minus 2001, this looks like a date, okay? So if I was scrolling through this and I saw this, I would go, oh, there's a date right there. But this is actually a mathematical equation. So I don't want to say that. I want to have this white space. So this is more explicit that this is actually a mathematical equation. So make sure you have your white spaces so that is explicitly a mathematical equation. So let's do another equation, and I'm going to do the plus sign. And if I run equation again, remember it's just going to print the last time it saw equation. So this will print the most updated equation, and you can see there's 13 right there. Let's do another equation, and this is the multiplication sign. It is the asterisk, also known as star. All you have to do is shift 8. So 10 times 3, and if I hit run, there's 30. Pretty simple so far. Do another equation. Now we're going to do the division sign. This is the forward slash, and 10 divided by 3 is 3.33. Don't get confused with the forward slash and the backslash. If we did use the backslash and try to run it, your computer is not going to understand what you're doing. It's just going to say unexpected character, and it does not know what to do with it. So make sure you're doing the correct slash. It's the same button as your question mark on your keyboard. So those are the basics that we'll use almost all the time, but sometimes you'll run into a few others. This next one is going to be something called floor division. So I'll make a little note for you. Floor division. How do you spell division? I'll do equation again, and floor division looks like this. It's 2 of the division signs. Now 2 of these division signs will still do normal division. It'll still do our 10 divided by 3. 10 divided by 3 you saw was 3.33. But watch what happens when I print floor division. It's just 3. A lot of my followers have asked me, well, is this just rounding? The answer is no. Even if the answer was 3.999, yes, naturally it would round up, but it's actually not. It's just getting rid of those decimals. So whatever the integer is on the left side of that decimal is what's going to be remaining. So that's why it's just printing 3. You might ask yourself, when would I ever use this? Well, you would use floor division when it comes to any mathematical equations. Maybe when you want to show the average of babies that was born in my small town last year. If the average came out to about 10.6 babies, well, I don't want to have the answer of 10.6 babies were born last year. I wanted it just to be a straight up 10, right? Because sometimes we just want those integers. I also use this whenever I'm writing video games. A lot of my followers want to create apps or video games with Python or with other languages. And when it comes to animation, floor division's gonna be what you want to use. The reason is because if you zoom in really close into your computer screen or TV screen, you can see all the little pixels. Animation has to do with all those pixels. If I'm trying to tell my snowball to go across my screen, I need to tell it how many pixels to go and how fast. But I can't have half a pixel. I can't have a quarter of a pixel. I need to do a full pixel. So when I'm doing animation, I'll use floor division all the time to make sure I have integer amount of pixels. The next one I'll mention is modulo, also called modulus. I think that's the official name is modulus. So let's do equation. And now I'm gonna do this percentage sign, shift 5, and a lot of people get confused with this. So if you've ever done a long division before, a lot of times you'll get a remainder. So this is still doing 10 divided by 3, but instead of giving me 3.33, it's gonna give me the remainder only. So there is a remainder of 1 when I do 10 divided by 3. So if I hit run now, it's gonna give me the remainder of 1. If I did 10 modulus 2, well, 10 divided by 2 comes out evenly to just a straight up integer of 5, so there's going to be no remainder. So if I hit run, it's going to print out 0. The last one we're going to be talking about is exponents. Let's write out this equation here, and we're going to do 5, and this is double times 2. If you don't know what exponents are, exponents is this number right here. We'll have a base number and then an exponent. The base number is getting multiplied to itself this amount of times. So 5 to the power 2 means 5 times 5. So 5 times itself 2 times is 25. And if I did 5 to the power of 3, that's 5 times itself 3 times. 5 times 5 times 5, which is 125. So exponents are really easy in coding. You can just do it like that. So now we're going to be talking about PEMDAS. If you've gone through school, you've probably heard about PEMDAS, and this is the order of operations. The order of operations, it tells us the order that we should run our equations so that our math comes out correctly at the end. Most of the time when we don't run PEMDAS, we don't do it in that order of operations, and then we will usually get a incorrect answer. So let's try this out. Write out some kind of equation, and we're gonna do this. 50 times 2 minus 4 minus 2 divided by 2. Now, I've taught before in my previous lessons that our computer reads our code like we read a book, left to right, top to bottom, just like this. So once it gets to our equation, wouldn't it just read it left to right? That's not following the order of operations. So let's see what happens when we do read it left to right. So let's do 50 times 2, 100. 100 minus this, so 4 minus 2 is 2. 100 minus 2 is 98. And if we do 98 divided by 2, that is a straight up 49. So the answer was 49 when we went straight across. So let's do this same equation, but let's do it the order of operations. The order of operations is this. This is what PEMDAS stands for. Parentheses, exponents, multiplication, division, addition, subtraction. So we should do it in that order. Let's see what happens when we do it in this order. So the order of operations tells us to start with parentheses. So let's do this 4 minus 2, which is 2. We don't have exponents, so we'll skip that for now. Multiplication is next. We will do 50 times 2, which is 100. Next, it says to do division. 2 divided by 2 is 1. We don't have any addition, so we'll skip that. Now do subtraction. 100 minus 1, which is 99. You can see that doing it from left to right gave us 49, and doing it the order of operations way gives us 99. That is a huge difference. Let's do this equation again, but this time we'll let our computer run it. So let's print equation, and let's see what it comes out with. It gives us 99. So what this proves is that your compiler actually does PEMDAS for you. So yes, it does do top to bottom, left to right, but when it comes to math and it detects it, it's actually going to run your parentheses first, then exponents, multiplication, division, addition, and then subtraction. It's going to do that for you. Now, a lot of you might be wondering, well, why are we even going over this if our computer's going to do this? It's because I have a lot of followers that say, hey, I have all these weird calculations that aren't coming out. And it's because if you don't understand the order of operations, then you writing your math might come out wrong because your computer is running order of operations for you. So make sure that you consider, am I writing this in a way that my computer can understand it so that it comes out with the correct answer? So if you want something to be ran first, put it in parentheses, so on and so forth. So good job with that. Let's build something with math, and let's see how we can use this to our advantage. Let's build a simple tip calculator. So if you're at a restaurant, sit down restaurant, you will at the end get a bill. So I'm going to create a variable called bill, and I'm just going to set this to $100. This will make my math a lot easier. Now, if my bill is $100, I also have an option to give a certain percentage of a tip based off of that bill. So I'm going to create a tip, and typically a good tip would be about 15% if the waiter or waitress did a good job. So we're going to say 0.15. Now that is not 15 cents. That is 15%, represented as a decimal. So what I want us to do is create a new bill, and I want to set this new bill to the new total after the tip has been applied. Well, I know that off of 100, 15% of 100 is $15. So my total bill at the end should be $115. So let's do 100 times our 0.15. Let's just see what that gives us so far. Let's print new bill. And if I run that, there's my $15. So now what I need to do is I need to add this now to my original bill plus 100. So there's my $115. So I've slowly figured out the equation to get the correct answer. But what if the table next to me, their bill was $23 and they gave a 20% tip? If I run this, what is it gonna say? If I run this, guess what? It still says $115. The reason it's doing that is because I did not write this program dynamically. So I hard coded these values here, so new bill is always gonna be this. So yes, it's great that we figured out this equation, but let's write this dynamically. So we'll say whatever the bill is times whatever the tip is plus whatever that bill was. So now it doesn't matter what these are. Now my bill comes out as $27.60 after my tip has been applied. If my bill was $230 and I gave a 10% tip, hit run, this is working dynamically. So that is awesome. So let's print out a nice thing for the user to look at. I'm going to use string interpolation and say, thanks for coming in. Your bill was, I'll use string interpolation by using squiggly braces. I'll say bill, you gave a tip of tip percent. Your new bill total is, and I'll do the $, and I'll do new bill here, and I'll put the $sign up here as well. Right now, it's just gonna print out the text exactly as I have it. Remember, I need to put in the F at the beginning of my quotation marks, and it's gonna scan looking for these squiggly braces, and it turns everything inside that squiggly brace into Python code. So now it says, thanks for coming in. Your bill was $230. You gave a tip of, this says 0.1%, we'll fix that later. Your new bill total is $253. So that's working nicely. Let's fix that percentage thing. We can just say whatever the tip was times 100, and now it's gonna give us that 10%. So now if I did 15, let's make sure that still says 15%. It does. And so if I have a bill of $100, tip of 15%, you can see my entire program changes because of that, because I wrote this dynamically. Thanks for coming in. Your bill is $100. You gave a 15% tip. Your new bill is $115. So good job if you went through that. If you have any questions, please let me know down in the comments, and thank you for showing up for lesson 4. If you like these videos, please like and subscribe, and I will see you in lesson 5. Thank you so much and happy coding.